Bismillahirrahmanirrahim. I'm here Muhammad Tayyib from Army Public School and College Khanewal. Your class is 8th, your subject is physics, week is 9th, online sport program. Your topic is 1 and your subject teacher is Mr. Muhammad Tayyib. Today our topic is kinematics and rest and motion. And our objective is at the end of the lesson, students will be able to understand kinematics and rest and motion. Day is 1. First of all, I will tell you about the kinematics. What is kinematics? The first thing concerning the motion of an object is its kinematics. The main definition is that kinematics is the study of motion of an object without discussing the cause of motion. I am again repeating the definition of kinematics. Kinematics is the study of motion of an object without discussing the cause of motion. We will study the type of motion, scalar and vector quantities, the relation between displacement, speed, velocity and acceleration, linear motion and equation of motions. Now I will share you the animation about the kinematics that is more helpful to you for learning.
All right, guys, today we're going to be talking about kinematics. What is kinematics? All of the questions you never had about how things move answered. Kinematics only describes a motion, not what actually causes it. Just keep that in mind. When we use kinematics, we will always use displacement and velocity, never distance and speed. Why, you ask? Because displacement and velocity can both be represented by lines, and for everything else you need calculus. So considering that nobody likes calculus, I suggest you stick to velocity and displacement. The next thing to keep in mind is that we live in a world without atmosphere, or at least we pretend to. Treat it like you're on the moon, but on Earth. Finally, remember that gravity is constant. The smart kids might say that gravity gets weaker with distance, so it's not, but we're going to pretend that it is. All right, let's dive right in. There are only a handful of equations that you will need for kinematic problems, and we'll get more into the specifics later, but just know that they can be separated into one-dimensional problems and two-dimensional equations. There are 3 different types of problems that you will encounter, the first of which is throw-up problems. It's pretty much exactly how it sounds. Pretty much anything you could throw up and catch or throw up and allow it to hit the ground is going to be a throw-up problem. A couple of quick things to keep in mind. First off, there is no horizontal motion, only vertical motion. Also, although initial velocity is positive, acceleration due to gravity is always going to be negative. Let's try an example.
See here Eric at the beginning of his motion. His velocity is currently as high as it's going to be, and gravity has already begun accelerating downwards. Here is Eric at his apex. His velocity is currently 0 in both directions, and he is now going to start traveling downwards. Eric has now finished his motion. He is at the very bottom, and his velocity is at its max again, but in the opposite direction.
The second kind of kinematic motion is called a cliff problem. This is sort of like a throw-up problem turned on its side. There is an initial x velocity, but the initial y velocity is going to be 0. It's important to realize that although there is a gravitational acceleration in the y direction, the x velocity is constant. So when you heave something off the side of a cliff, it's going to remain the same velocity in the x direction right up until it hits the ground. You'll also notice that since your object won't just be moving in a straight line, we're going to have to break up the problem into something called components. That means we take the direction and break it up into x direction and y direction. That just makes it so that we can continue to use the same equations and combine the answers in the end.
Next is a rest and motion. We see various things around us. Some of them are at rest while others are in motion. And the definition of rest is that a body is said to be at rest if it does not change its position with respect to its surrounding. Surrounding are the place in its neighborhood where various objects are present. You can see that in this slide, a body is said to be at rest if its position does not change with respect to a fixed point in its surrounding. For example, a book lying on a table is at rest. A bench fixed in a park is at rest. Next is the motion. A body is said to be in motion if it changes its position with respect to its surrounding. You can see that in this slide, a body is said to be in motion if its position continuously change with respect to its surrounding, change with time. For example, a flying bird, a boy playing football is in motion. Next thing is that the state of rest or motion of a body is relative. For example, a passenger sitting in a moving bus is at rest because he is not changing his position with respect to other passenger or object in the bus. But to an observer outside the bus, the passenger and the object inside the bus are in motion. Now I will share you the animation about the rest and motion that is more helpful to you for work.
Rest and motion. A body is said to be at rest if it does not change its position with respect to its surroundings. If a body changes its position with respect to its surroundings, then the body is said to be in motion. For example, suppose a book is lying on a table. The book is at rest with respect to the surroundings. But the earth is revolving round the sun, therefore anything lying on the surface of the earth is also in motion. We can thus conclude that the book is in motion with respect to the sun. Let us suppose a person is traveling in a train and he passes by another person standing alongside the track. The person standing along the track will see the person and everyone else in the train as being in motion. But all the persons sitting in the train will be stationary with respect to each other. So, from the above examples, we can understand that an object may be in motion with respect to another object, but may be stationary with respect to a third object. According to A, C is in motion, but in relation to B, C is stationary.
Next is your assignment. Learn and write kinematics and rest and motion. That is given on your textbook, page number 29, 28 and 29. Thank you.